Welcome to another episode and video on my Raspberry Pi 1 running Raspbian Linux and connected by Fischertechnik Plus to serial by this connector, network by this cable, and by GPIO to breadboard by this band cable. And of course the Raspberry Pi itself is under this Fischertechnik Plus, and this cable here is connected via USB RS232 converter cable to my laptop. And this is the breadboard with two chips, of which I used one being this one, and the band cable is connected to several wires, but the most important for this project are this brown wire and this yellow wire, and of course these two orange wires, which are connected to ground and voltage coming from the Raspberry Pi Plus, Raspberry Pi, not Plus. Anyway, it is about this chip, and there is an MCP 23008 I2C extension, which extends the normal number of GPIO pins with 8, and it is supposed to be able to to control for example these LEDs. Last time I checked by example two LEDs, they function fine, so the LEDs are alright. I did also check the wiring, the signal I mean, and I did that by means of PISCOPE and the oscilloscope, and these are of course the wires from clock and data from here. And you already noticed these two probes. I'm going to use them for the other side of the chip. See if there is something from there. Because so far, a couple of episodes in on I2C, the LEDs haven't shown anything yet. And granted and admitted, yes, the wiring was not correct in the beginning, but it's now, and yet it didn't do anything. So the question is, does the chip work? How do I check that? Well, for example, by measuring signals from this side, not just from this one, but from that one. Also, last time I found that the wire, that the signaling on PISCOPE is quite similar to the oscilloscope, depending on the setting of course, so that should be alright. Anyway, enough talking, let's go to the VNC, virtual network computing session, and see how I can maybe hopefully get things right this time. If not, I have to make up for an other strategy. So here we are with the two programs from last time, demo and wiring, where the wiring still has the problem that there is some undefined unlogical delay here, and I still have to find out for here, this 100, it is supposed to be a port, but I can't figure out which, why and how. It says pin mode plus 15, pin mode 100 plus 15, but pin mode for the Raspberry Pi can only go to so much, but not 100. At least not that I know. One thing that I should do is, why am I doing this, by the way? I should just say I2C detect channel 1, because it is channel 1. Oh, by the way, this is once again, if we look here under in the serial terminal, which is the serial cable that I showed in the beginning, and this shows that I2C is loaded, so everything should work. Lo and behold, the chip is detected again. Wow! I am pleasantly surprised. Last few times the chip did not respond. This proves the chip is there. Wow. So, will the demo and wiring work? Let's see. Oh, from last time as well, I have to execute the demo using sudo, otherwise it won't work. The output will be there, but there will be no access to the GPIO, which means there will be no access to the chip. So, and of course I have to do it like this. And for those that are not quite familiar with Linux, this indicates a program that you have made or that someone else has made, but is not a system command. This way you execute such a file. Look at this. For the first time ever that I can see that it actually works. Let me change the time base. Look at this. Oh, I'm very pleasantly surprised now. Alright, one is not working. But that will be my program. Oh, I'm very happy now. Still, the question, why is it working now while it hasn't been working for all these past episodes? That is a very big question for me right now. What's the time base right now? 20 microseconds. Wait a minute. Look at this. This is 100 microseconds. And milliseconds. Okay, now this is equal to what you see on PISCOPE. But this doesn't show anything at all, if you understand what I mean. So when I go back to right here, this is much better to watch at. So now you can see that it actually has each of those stripes, each of those lines actually shows like this. But why, again, why does it work now? And didn't it work so far? Because you can see the walking LEDs. And actually it has a delay of 30. And I can of course delay that. It's a very small delay. So this makes me wonder, let me interrupt it, what is the result if I run the other one? Okay, RaspberryPi, and that doesn't do one single bit. And then I'm talking about this program. It hangs on a while. And this also shows that 100, pin mode 100, isn't anything. So the pin mode is wrong. That I now know for sure. Okay, let's get back to demo. And yes, there we go again. And yes, it goes fast as lightning. What if I remove the light a bit? Oh yeah, that's better. Now you can watch it without the light a little bit better. How about changing the speed? Yeah. Although I find it rather curious that the last LED isn't functioning. Why? Oh, very clear why. It's not connected. That is why. So I take another wire. And oh right, there is already a wire connected there. So I'm putting this wire right here. And I put this wire right here. And now all wires are working. Yep. So now I have, oh wait, of course, this is an LED I don't need anymore. It was just for checking. So now I have six LEDs set up, and these wires can touch each other because it's all ground, which also means that the different resistors that I've put here, and let's take a look at the schematics. These, let's say, these two are the same, and these are the same. Well, there are 6 LEDs now, so these resistors are the same, and these two are the same. So these two haven't been implemented yet. And with this LED that I removed, I have to be careful putting it in the right direction. And pliers. Let's hope that will work. So, first of all, inserting another LED, which won't work immediately, of course, because I have to add another resistor and another wire. The wire isn't a problem, I have it. Another resistor is not a problem either. So let me add this on the fly. One here. No. This will do. And then another wire there. So let me add that and see if the program has to be changed or not. And then after placing LED number 7, I of course had to wire it, finding out that I made a little wiring mistake, but what's wiring anyway. This is working, this is working, but the lights are off for some weird reason. So now I am very convinced that the chip is still working. Yes, it is still working. So once again, the demo. And there are the LEDs. Again, 7 in total. So I am completely convinced that number 8 will work as well. But I have to relocate the chip to make place for it, etc., etc. So I'm not going to do that, at least not now. However, I am still wondering why is the chip doing everything now while it didn't do it before. I still don't get it. Okay, so this is quite obvious, working quite fast, and let's stop this one because I have another one, the wiring. Why is the wiring not working out? Well, if I recall, there are only 40 pins, and pin mode, when I use GPIO, oh wait, I can do that in another way as well, of course, because this is input and pin mode. I just recall something. I have several ways to induce or to actually do something with the pins. Let me check. New tab works better. And I have other C programs as well, because of the projects I did in the past. So let me check them out. GPIO class, oh wait, this is C and not C++, which I used previously. That is another one, a very different one, but can't hurt to check. This is going way back into history. And using the GPIO, and this is GPIO 4. So this is a very different one. I can't use this. And GPIO test is C as well, while I'm now using ANSI C. Okay, so much for my idea. Still wondering why, and I have to get a map of the GPIO. And this is what I was looking for. The pinout GPIO layout of the Model B. Well, if I exit this one, you can see that it actually denotes the Pi3, the Pi3 B+, but it has the same layout as the Model 1 B+, which I am using now. So, as you can see, it has 40 pins, and looking at the GPIO number, they're slightly different, but 17, etc, 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 9, 11, 26, it doesn't come any close to 100. And guess what this says? Pin mode 100 plus 15. So where's the 100 referring to? Well, this is obviously the port that I'm using, because it is exactly the same as this one. But how about the one? How about this one? So I took this from. Let me remove this one. This is the one I took. So this one That's the exact same thing. Outputs a single 10-bit binary count and pauses when the button is pushed. You need the button, but that's one other thing. Apart from that, what's the 100? And last, 15 is an input with the terminal enabled. Alright, so for this I need some schematics. Change. I can't use it right now. I don't mind. Let's get back to demo. And right now I'm more than happy that my chip is working, and that the setting which I ended with last time was 1 millisecond, but it clearly can't be 1 millisecond like this, because this is only at 20 microseconds. You can see this one. Maybe I can get that makes no use. That's no use. Oh, by the way, here you can see it even more interesting. How many there are. Yeah, quite interesting. Anyway, quite a relief that things do work after all. How to continue? Well, I do have, of course, still this program that is not working, but I need to adapt. I need to change the circuit for this. I only took this one to have another bit of program to check out the chip, but it doesn't work the same way. And that is, I think, for next. For now I'm quite happy, but still mysterious why it didn't work out the first time. And by the way, these two probes I had intended to put somewhere along here to measure signals, but it turned out to be not necessary. And these two probes belong to these two lines, which are doing nothing because they are not connected. And that's it. And with this I come indeed to the end of this episode. With this camera you can get even a better view of the walking LEDs, LEDs. And it looks quite nice. So it turns out that the value of the resistor doesn't really matter, although they are not really much different. One is 330 ohms, the other one is some 600 ohms, I think. Anyway, it doesn't matter. What does matter is the chip is okay, the wiring is okay, the program works quite nicely. By the way, I changed the program massively. But you know that if you have watched the other my other videos on this. So the original program may not do what this program is doing. That is for sure. Thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment. You can also follow me on Twitter. If so, please retweet, like and leave a comment. You can also follow me on Instagram. Please like and leave a comment. You can show your support and appreciation by donating. More information please on my website or at the start of the video. And you can also choose to become a patron and by monthly pledge have your name mentioned either on my website or with my videos in one or two ways, depending on the pledge you make, but it's up to you. For now, thank you for watching and bye bye.